Hello guys, we're going to talk about trigonometry today, and it's all to do with learning the basic functions of the trig ratios. There are about 6 trig ratios, but we're going to concentrate on just the 3 that we should be expected to know how to use during the GCSE or in the GCSE exams. So first thing, it will be good to have this idea of the trig ratios being associated with sol, car, toi. And I'm going to tell you what all this means in a second. Now, say we have a triangle of this sort. So a right angle triangle associated with right triangles. Say we have something like this, and maybe this angle here is 35 degrees, and say we were asked to find this length here from here to here, and we're given this part here. Now in GCSE, if you're asked to find this x, it's important to know how this SOHCAHTOA in trigonometry applies to your triangle here. In a right triangle like this, it's important to know what labeled angle we're dealing with. This 35 degrees is the labeled angle. So if we look at this angle, the opposite bit to the angle is the x bit, so we're gonna call this our opposite line to that angle. So this is opposite to the labeled angle. It's very important we know what we mean by opposite. So opposite to this labeled angle is what we've got here for x. Now the line here, which is opposite this right angle, is what we call the hypotenuse. So I'm going to write hypotenuse there. It's very important, like I said, to know what all these terms mean. So we have the opposite line to this labeled angle, and we have the hypotenuse, which is opposite the right angle. And then this bit here, after you've recognized which is the opposite and which is the hypotenuse, this last bit here is called adjacent. So I'm going to type that in as well, or write that in. So this is adjacent to the labeled angle. Now, in finding x, I have information about the opposite being x to this labeled angle, and I have information about the hypotenuse being 12 centimeters. So because I have these two information, opposite and hypotenuse, I'll be using the sole part of the trig ratio. Now what does that mean? It means I'll do sine, some people call it sin. Sine, the full spelling will be sine 35 degrees, but we tend to write it as sin, if you want to pronounce it that way. So we have sin 35 degrees, but I call it sine. Sin 35 degrees equals the opposite divided by the hypotenuse. So in this case, the opposite to the labeled angle is x, and hypotenuse is 12 centimeters. Now, to find x, it's very important we know that we have to eliminate this 12 here. Now, because the operator between the letter and the number is a divide, we need to eliminate 12 by multiplying 12. So if I multiply this bit by 12, I'll be left with just x. Now I've got to multiply this bit by 12 as well. So I'm going to write sine 35 degrees times 12 to get my x. Now using the online calculator, sine 35 degrees Let's see if we can quickly select that, or we could just use our normal calculator, which I've got here. So sine 35 degrees is 0.5735. If we times that by 12, we will get 6.882, approximately 6.9 centimeters. So I'm going to write that down. Our x is 6.9 centimeters. So that's the answer to that bit there. I'm going to put another slide on here. Now, if we have that same triangle, I just want to show you something. That same right angle triangle, and we have the x here, and we have the 12 centimeters there, and we have 35 degrees here. And the question is, find x. Now, the labeled angle here, the opposite definitely is this bit here. So I'm going to just write OPP for opposite. The opposite side to the right angle is definitely your hypotenuse. I'm just going to write HYP there. And of course, to this labeled angle, this bit here is the adjacent. So if I write that as ADJ. Now, the information I have is the ADJ and the hypotenuse. Now, if I write my SOHCAHTOA again, as in SO, CA, and TOA, you can clearly see that the bit that has the adjacent and the hypotenuse is this cos here. So I'm going to write cos, so it's the full spelling is cosine, yeah, cosine 35 degrees equals the adjacent, which in this case is x, divided by the hypotenuse, which in this case is 12. All right. Now you could shorten that to just cos 35 degrees. Now to find this x, okay, I am going to say x equals 12 times cos 35 degrees. So our x, using my calculator that I've got here, becomes cos 35 degrees, which is 0.8191 times 12, and then we end up having 9.8 approximately centimeters. That will be the answer to the x here. And the last bit of the trig ratio I would want us to talk about is this bit here. So say we have the same triangle, the same right angle triangle, and we have an angle to be here, for example, and then I probably write my x here, I write my 12 centimeters here, still using the 35 degrees. Okay, now this labeled angle here, this is the opposite. Let me use a different colored pen. This part opposite this right angle is definitely your hypotenuse. Remember, your hypotenuse is the bit opposite your right angle in your right triangle. And so I have hypotenuse opposite this, definitely will be adjacent to the labeled angle, which I'll represent by writing ADJ. The information I have here is opposite, which is the x, and the adjacent, which is the 12. So if I write my SOHCAHTOA, so ka and toa. Now the bit that has got opposite and adjacent is the t, which is tangent. So we normally would just write it as tan. So tan 35 degrees is the opposite divided by the adjacent. So the opposite is x and the adjacent is 12. Same procedure. My x becomes 12 times tan 35 degrees. Now using my calculator here, my tan 35 degrees is 0.7002. So we're going to times tan 35 degrees by 12, and what that comes to for x is 8.4 approximately centimeters. So that's how to use the basic three trig ratios. Like I said, there are 6, but we will concentrate for the purpose of GCSE on 3 trig ratios, which is the sine, cosine, and the tangent. If I write this properly, because that looks like, let's write that as a proper A. Okay, so catois. Now, however, the question might change. You might be asked to actually look for the angle instead. So I'm going to put an example up on the board here. So say we have something like the right angle triangle again. So if I put my 90 degrees there, doesn't really look like it, but yeah, let's just make it proper. Let's draw it properly. So that was a right angle triangle, right triangle, and we were told to look for the x, the angle here, okay? And you were given this as your 12 centimeters, okay? And here you were given it to be 6.9 centimeters. Now, the information we have to this labeled angle, we've got opposites of that angle, which is OPP. We've got the hypotenuse, which is always opposite the 90 degrees. So this is your HYP. If I write HYP there. And obviously this is your ADJ, which is your adjacent, okay? Now the only information you have here, you have information of the opposite, which is 6.9, and you have information about the hypotenuse, which is 12 centimeters. Now writing your trig ratio out, so, and then car, and then toi. Which are we going to use? We have opposite 6.9, we have hypotenuse, which is 12. So opposite and hypotenuse, we're going to use the sine ratio. So if I write sine or sine x degrees equals, the opposite is 6.9 divided by the hypotenuse, which is 12. Now, to find what this is, the first thing we want to do is ensure that we write what sine x is first. Your sine x degrees here is, let's do 6.9 divided by 12 and see what that gives us. So on the calculator we have 6.9 divided by 12, and that's 0.575. So 0.575. Now to find x degrees, we've got to use what we call the arc sign. Now, arc sign is written like this. So if I write sine or sine, and then to the exponent -1, and then we put the 0.575 in there. 0.575 in there. Whatever this is what our x degrees will be. So how do we punch that on the calculator? All we have to do is press the shift key on our calculator, press the sign, and then put the 0.575 in the bracket. And whatever that gives us, clearly our x is 35 degrees. And that tallies well with what we had at the very beginning. If you look at it, when we said this bit here was 6.9, I think it was this slide here. No? Let's try this, 6.9. Yeah, so we got 6.9 for this bit here when the angle was 35 degrees. And actually that is correct now, because when we knew this was 6.9 and we were trying to find this, we got 35 degrees as well. I think I could bring that up on the screen for the scientific calculator, where we have can't remember where I got that from, but yeah, we definitely would have the arc sign on every scientific calculator, so this shouldn't be a problem to do. Just press your shift key and press your sign, and you'll be able to get what your x is. Hopefully this should help us in understanding the basic trig ratios for right triangle. Okay, bye.